Hello, my name is Jacob, and I decided to do my extra credit project um, within Minecraft for the first project. So I built the entire circuit using redstone and a few other things like command blocks. And I'm just going to walk you through how I accomplished it. So just a few things going into it. Based on the first circuit, there's C3, C2, C1, C0, and then there's P1, P0. These are all within the circuit that everyone had to build. Uh, and these are just the respective colors, so when we're looking at the circuit, you'll know which pieces go where. And then I have a clock that is handled somewhere over there. Here we just have a double inverter. All it does is just extend redstone signal, just the way redstone works in Minecraft. I can only go so far before it loses power. So doing this, uh, activating lever, all it does is extend the signal, and it's the same tick. Here we just have an inverter. This has a 1 tick delay since it uses a repeater. All it does is just invert the signal. Here we have a 2-input OR gate. All my gates were 2 inputs, not anything more. So one of these is lit, then the output is on. So this also has a 1 tick delay since it's redstone repeaters. And then here we have the 2-input AND gate. This requires 2 signals like an AND gate, and there we have it. This is also a 1 tick delay. So this is just an overview of the circuit. We see our C3, C2, C1, and C0. There's also our P1 and our P0. This is a circuit that we had to build. This was these pieces here, and over here are the pieces that were given to us in class. And I had to make them in Minecraft so that they would function and make a working maze. So I used a minecart entity and command blocks. That's just some Minecraft stuff. It's kind of difficult to explain, but the actual circuit isn't too difficult to explain. So the way the circuit works, this is our collision detector. See, collision detector, and takes C1 or C0, C1, C2, and C3. This is just registering if there is a block to the left, right, above, or below the minecart. And based on if there is or not, it will output a signal using comparators. So this is just an overview of the circuit. So we have C3 going into this AND gate as well, and then this AND gate. We have C2 going into that AND gate, this AND gate right here, and I believe that's it. Yep. C1 just goes into this AND gate and this AND gate, and then C0 only goes into this AND gate. And then all these AND gates are connected to OR gates. That's just an overview of this main circuit that we had to build. My schematic for the circuit, I believe, was not the most efficient one, but it still managed to get the job done. Now, since this is now P1 and P0, I had to figure out a way to translate that into a move and also translate it back into previous moves. So I had to, instead of doing, which I could do like a D flip-flop or anything that holds states, I use just wireless redstone, which is just a Minecraft mechanic. So this is a simple 2 to 4 decoder, with this being, these are labeled. This is the right, this is a left move, this is a down move, and this is an up move. So based on P1 and P0, it will output a signal to these command blocks and begin the maze. So this, in order for everything to be synchronous, I added a clock. which allows time for the circuit to update its state and then output a signal to the command blocks. So this will run through the entirety of the maze. The way the wireless redstone works is based on which one was activated. So if we look, this one was activated. It will send a signal to the command block that sits on top of it, and it will place a redstone block here. Is probably the easiest way I figure out how to do it. I'll outputs a signal to P0 or P1 respectively, and allows the circuit to update, and in time it will reach back here and output the move. So as you can see, minecart is slowly going through this maze, and once it gets here, it will reset and continue to go through the maze. So I'll just let this finish up. And there we have it. Restarts back there. So I can just end it here. This is just the clock circuit. P1 and P0, C0, C1, C2, and C3. So this took a couple hours to make, but pretty happy with the results. I think that's it. Thanks for watching.